Okay, so we're going to have a look at another question from the 2022 HSC Standard 2 Maths paper. So this is question 26. So we're told the diagram shows two right-angled triangles, ABC and ABD. We're told AC is 35 centimeters, BD is 93, angle ACB is 41, and angle ADB is theta. We are asked to calculate the size of angle theta to the nearest minute. Okay, so let's draw a little copy of this diagram in our book. So we have a big triangle like this, a major triangle, and then a smaller triangle inside it, sort of something like, let's try and make this a little more accurate, something like this. This is 41 degrees, this is 90, this distance is 35, this is theta, this distance is 93. Alright, so first, if we look at the smaller triangle, if this angle is 41, we know the angle sum of a triangle is 180. We can immediately calculate this angle. This angle has to be 180 minus 90 minus 41. So 90 minus 41 is 131. 180 minus 131 is 49. So this is 49 degrees because the angle sum is 180. We can also work out this angle here. This angle here this angle plus 41 must be 180. So this must be 139 degrees. So before we've even done anything, we've found two angles that we can use to help us find angle theta. So now, how could we try and find theta? Well, if we look at the diagram, we don't know this angle, which we could call phi. If we knew phi, we could find theta. Or we could just ignore phi and we could find this distance along here, which we'll call length L. If we could find length L, we have an angle pair side here, an angle pair side here, and then we could use sine rule. So instead of trying to find phi, let's try and find length L, which is the hypotenuse of the smaller triangle, and we can do this using trigonometry. So we can use cosine rule. We can say cosine of 41 degrees is adjacent, which is 35, over the hypotenuse, which is length L. This means that length L is 35 divided by cosine of 41 degrees. And if we wanted to be exact with our sine rule, we could leave this like this, but we could also decimal approximate this. It's going to be fairly common in these papers to see decimal approximations at this stage. So 35 divided by cosine 41 gives me 46.3754. 46.3754 ... And we can just use 46.3755. So we'll say this is 46.3755 when rounded to 4 decimal places. Because this is a number we're using in our working, it's better to keep it to more decimal places rather than less, because we need the answer to the nearest minute. So now that we have this length, we can use this length and the angle theta, along with the angle 139 and the length 93, in a non-right angle sine rule. So we have sine of theta divided by L, which we just said was 46.3755, this is 4 decimal places, is equal to sine of 139 divided by 93. So multiply both sides by 46.3755. 46.3755. This gives me sine of theta is equal to 46.3755 times sine of 139 divided by 93. If I take the arc sine of both sides, I get theta is arc sine of 46.3755 times sine of 139. It's best to leave it in this form until we're evaluating it. It's better not to decimal approximize this expression if you can avoid it. So this tells us, we won't use a therefore yet, we'll say this implies theta is equal to Shift sign on the calculator. Make sure your calculator is in degrees mode if you're going to do this. Make sure it's not in radians mode by accident. 46.3755 times sine of 139 divided by 93. This gives me 19.0959 ... If we convert this to degrees and minutes, this is 19 degrees 5 minutes 45.45 seconds. So the question says calculate the size of the angle to the nearest minute. So the nearest minute is going to be 6 minutes. So therefore theta is 19 degrees and 6 minutes to the nearest minute. And this is the answer to this question. So now let's have a quick look at the marking. This is worth 4 marks. So right at the start of the question, you'll get 1 mark for an attempt to solve. So right at the beginning, if you start using algebra to find missing angles, or you start using algebra to set up formulas to try and find sides, this will get you 1 mark. Sort of anything at this point, anything roughly close to trying to find an angle or a side. For a second mark, if you're using this method, you will need to find an expression for a missing length or equivalent. So in this case we needed an expression for a missing length, but if you were doing something else you would have to find the equivalent to the expression for length. The third mark will be for the working associated with finding the angle. So you'll now have the use of sine rule, plugging in numbers, trying to solve for the theta. For the fourth mark, you will need 19 degrees and 6 minutes, and this will need to be rounded to the nearest minute.